Okay, let's talk financial equations overview. This is inspired by the final project here, in which you're going to need all three of these things. These may seem like very different formulas, and they do produce different things. Let's just start with that rundown. Zoom in here a little bit. Produces the monthly, well, we use it to produce the monthly payment amount, but really it can produce any periodic payment needed to pay off a loan in X years at Y interest rate. Sorry, I'm using letters because I'm trying to be general here. So and the third argument is the size of the loan. So there's three things that you put in. And in fact, in all of these, there's three things that you provide. It's just what you provide depends on the formula that you're using, which determines what you're trying to look for. X and Y are always going to be there. And in our situation, we're always dealing with these monthly. So actually, I should state this not in X years, but I'll say in X months, because the way we use this is monthly. And then I guess the last thing I would amend here is that if we're sticking with this monthly theme, this really needs to be a monthly interest rate. And so a monthly interest rate is going to be produced by getting the annual interest rate and then just splitting it up into 12 equal parts. Okay, so we've got ourselves PMT. Just starting to build my little table here to compare these three things. And now let's do PV. And PV produces the maximum amount you could borrow if you can pay Z dollars per month for X months at Y monthly interest rate. Okay. And then finally, there's FV, and FV produces the future value in an account if you deposit Z per month for X months at Y monthly interest rate. Okay, let me get wrap text on there. So first of all, I hope that you can see the similarity between these three things and the ending of the phrasing X months at Y interest rate. That's always the same. And that's actually the beginning of each formula is you take whatever it is and you put in your interest rate and you put in your number of months. Now, typically, when we do this, we actually take our interest rate and we divide it by 12 because we're trying to get to that monthly rate. That's the connection there. Then what comes next is different for each one. This is how much the loan is in PMT. In PV, it's how much I can pay per month. And in FV, it's how much I'm depositing per month. So this last number is going to be different depending on which of the three you're using. But one thing that's consistent is it's always going to be a negative number because of how the algebraic manipulation works and what comes out the other end. So now let's just do a quick, practice problem of each type, and we'll take a paragraph and then we'll put it into context. So Ben is buying a car. He can get a 8.23% APR. He is looking at a $25,000 car. He wants to get it done in 5 years. Okay, so from here, let's zoom in again. I know that what I'm looking for is, well, I actually didn't say it, but I already know because I'm writing the question. What is his monthly payment? So equals PMT and then the 8.23%. Often you'll be able to use cell references here because you'll have the information organized, but if you don't, you can type it directly in. 5 years is 5 times 12 number of months, or I could just write 60. And then this last one is minus 25,000. Very important. Don't put the comma here because that confuses Excel and it'll give you a weird answer. So this is $509 and you know, that's a big car note, but it's for some people with, pretty good paying jobs, I'd say up in the 60K, 70K range. This is doable at 10% of the income. Common mistakes: forgetting to divide by 12 should be a very noticeable difference. This is not a reasonable car payment. This is a very crazy car payment. I mean, this is like millions of dollars for your car. And you would notice that if you multiplied the 60 times this number, right, that this okay, sorry, I had some kind of neighborhood thing. I predict my millions of dollars was not a very good prediction. This is gonna be a plus $100,000 car. So anyways, the point is that not dividing by 12 should be a pretty self-evident problem. When you look at the total that you pay, which I can do by just taking the number of months times the monthly payment, it should be more than the car, but it shouldn't be a crazy amount more than the car. I mean, depends, I guess, on what you mean by crazy, but I'm in the same ballpark here. $30,000, $25,000. That makes sense. I'm paying interest. This is actually a pretty high interest rate. That's the way things are right now. Depending on my credit score, it could have ended up being various things, but this is where I ended up. So this is how you do the PMT formula. And by the way, the difference between how much I pay total and that original price tag, which is what I could have paid if I had the cash for it, is the amount of interest. Okay, let's move on to the next situation. So in the next situation, we're going to approach this question differently, which is Ben's buying a car. He can get 8.23% APR. He wants to get it done in 5 years. If he can afford only, I don't know, $250 monthly payment, what can he afford to borrow? So we're turning the question around. That's why I call the PV formula the responsible borrowing formula, because you're considering the question not from the starting point of I've found a car and I want to buy this, but I can afford to pay this much per month. So what can I afford to borrow on that? Same thing here. I'm just gonna put 60 directly in, and then I put my minus 250 here. Again, the negatives goes in there at the end because that's the way all three of these formulas work. I'm gonna zoom in a little bit. This is not an incredibly high amount of money, and it would limit my ability to buy cars. I'd have to buy a used car with fairly high mileage. But when you do this in the project, you want to pay attention to the number and you want to then go shopping below this number. That's the whole point of doing this step first, is it gives you a bar. And so it helps you say, oh, I'm not searching for something beyond this. All right. And then the last formula is for a totally different context, but it's a similar formula, which is the future value formula, which is Ben is not going to buy a car. He is going to put that $250 per month into a savings account. Forget savings account, into a mutual fund which promises an annual return of 12.5%. Now, the thing that's complicated about these is that when you put money into mutual funds or stocks, it actually doesn't have a regular return. It depends on what's happening in the stock market. So we're making a prediction here that we can't be guaranteed of this result. There are other financial instruments like certificates of deposit, savings accounts that will have a guaranteed rate of return, but those things can change too. I think not the certificate of deposit, but the savings account can go up or down based on what's happening in the world. Anyways, let's use this one just to see what happens. So again, 12.5%, but I divide it by 12 because I need to make this monthly. I forgot to say how many years, but I'm going to do the same as the previous problem, which was 5 years. So I'll do 5 times 12, could write 60 by 1, and then I'm putting in $250 a month. So if I can do this for 5 years and I get this return, I'm going to end up with $20,000 of savings, which would be really nice. You know, typically it's interesting to ask about your mattress figure, which I call the amount of money that you deposited with no return. So if I put this in my mattress and I didn't earn any interest, then I would be sitting at $15,000, which means that the interest I earned is around $5,000 for this. But again, now all that depends on the 12.5% return. So those are the 3 formulas that you need in the final project. You need to do PMT. You also need to do PV, and you need to do FV later on when you're considering what could you have saved if you don't spend it on a car and you find other ways to get around, or you use the old car that you have right now. Okay, hope that helps. Always feel free to send me messages if you want specific videos made, specific tasks, or need help. That's a good way to get help asynchronously. All right, good luck.